Right, like I said, I'm Benji. This is Daniel, he's my son. It's like from yesterday, the photo. I work on a bunch of stuff. I've been with Microsoft for the past 2 years. I worked on like the security offering, securitymicrosoft.com. And for the past few months, I've been doing re-architecture of some parts of Excel. I've been working on Node since like 2015, I think, and I do a bunch of other stuff. I worked on promises. I worked on like some testing libraries, some state libraries. I did some other stuff. My opinions here don't represent Microsoft. They don't represent any other organizations I'm involved with. They don't represent EC39 because I will be talking about a proposal. For those of you who don't know, that's a standards body I'm involved with that specifies JavaScript. They don't represent WG or Node. In fact, Microsoft aren't even paying for this. DaFED are paying for this. I'm on my pay time off, so feel free to diss Microsoft as much as you want. It's a nice employer, but like I'm here for the community. So who here does mostly JavaScript? Yay! I got everyone to move. Great. I'm not a designer. I know like DaFED has some people who are good with like visual stuff. The slides may drive you crazy. I apologize for that. And this is not a huge conference. Let's please use that. I like that part. So like, please interrupt me. I know it's very hard to get people to interrupt, but I can try. All right. I intentionally made too many slides, so interrupt me. I can go on till like 12, if you let me. So like the idea is to pick and choose, and let's make it interesting for you. So the first thing I noticed is stuff we don't understand. We usually give fancy names, and we try to like make it sound clever. So like, does anyone know what streams are in principle? Anyone want to take a guess? Continuous data. That's a good guess. Right. We'll be talking about that. We'll be talking about what streams in Node are. They are like dumpster fire, and why they stopped being dumpster fire and are now fun. Right. So some definitions. A producer is something that creates values, and a consumer is something that reads values. A setter is a magic function that takes something and does whatever with it. It's just for side effects. And a getter is a function that takes nothing and returns a value. It's like magic. It creates something out of nothing. So when we asked in like the DaFED social, who here is like an expert in Node streams and like everything is great and all that, like that number was 0. And there were years like 2018, 2019 where we meet like twice a year usually to sit in person and like code. And like, we didn't know either. Like, there were people who originally wrote them, like Streams 2.0, they left, and like, we were stuck for a while. So it is tricky, you are not crazy, and we will see why. Like the person in the back said, it's basically something that lets us process data in parts. It's like, continuously get data and process it. So this is C. I show some C to scare people, or like, there may be some C++ later. Is this a stream? Anyone want to guess? This is the most regular way to like open and read data from a file in C. Is it a stream? Yes, good answer. It is a stream. The background is like an angry, never mind, Dennis Ritchie. This is a stream, right? It meets our definition. If our definition is it's just something that has processed data in parts, this is a stream. And it's like the same for fopen in PHP, doesn't matter the language. In C++, they like did the next step, and they just like literally called the IO facilities IO stream as a giveaway to make it simpler. What about this? Is this a stream? Oh, that's tricky. That's good. Yeah, so there was a famous like a scientific paper called "Your Mouse is a Database," the basis of RxJS that was mentioned in the previous talk. This lets us process data in chunks, right? Every click, we process the click. We don't have to process all the clicks in advance. It sounds silly, but it meets our definition. What about this? This is just a function that returns a function that returns the number 1. Is this a stream? Yes, good. It's basically just like the first one is just a factory. It gives us like something that gives us a value. and then that just returns us numbers. It's number one, but it can be anything. It can be a range, it can be whatever. So here I did something a bit tricky. I took all the arrows from the example above, and I inverted them. Is this a stream? So I'll go over the code real quick. We have a function called getF. It defines a variable, and then it just like calls the callback it got with that variable, and then we console.log that. Is this a stream? Not so obvious, right? Like, what about now? So, like, for those of you who saw RxJS, the example here and the example here, they're the same example, right? And this example is intentionally confusing. You shouldn't feel bad if, like, you had a hard time, like, figuring out if it's a stream or not. RxJS is basically taking this example and, like, inverting all the arrows, but it's still a stream. Instead of us asking for the next value, it gets pushed to us, and that's really fundamental. So, observation. Do we want philosophy for, like, 5 slides? Yes, good. All right. Streams are all fundamentally either getters to getters, this, or setters to setters, this. These are basically streams, right? So if we look at like a JavaScript iterator, that's like an array iterator. So those of you who don't know, arrays and various things like node lists have a symbol.iterator. You call it, it gives you something back. You call next on that, next, 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 and eventually it will returns this value with like done true and like the value. So the JavaScript iteration protocol is just a getter to a getter. Now with event listeners, showing it's a setter to a setter, it's a bit more tricky, right? If I show the like RxJS-like example, and for those of you who don't know, observables, RxJS, is like super simple event emitters. It's like way, way, way more primitive. It's like, you can see the setter. Like the subscribe is the first one, and then the callback here. So the getter to getter is like easier to grok on the first call. You ask me to like bring you the iterator, and then I just call a function to bring the next one. And Rx is just wraps functions. CFile API. This is the first getter, the fopen, and this is the second getter, the fread. So in a stream, either the consumer can ask for data, or the producer can push it. That's very fundamental. In the setter case, like event listeners, the producer pushes the data. That's a push stream, right? I subscribe to it once, to a push stream like RxJS, and it's the opposite of lazy. Once I subscribe to it, it pushes all the values at once. I have no control. It controls like the flow. In the getter case, like iterators, the consumer, like who are you, the developer, asks for the data each time. So in this example, I have a 408 that iterates a stream. This is like a regular Node.js fs create read stream. You can do that. You can for loop streams in Node. And it won't ask for more data until data wait finishes. It will do some buffering, we may cover that, but very fundamentally, all the control is in the consumer. You can create a stream, never access it, and no data will be pushed. And of course, this can be explicit. I can get an async iterator, I can call next, and the await may fetch the data. So a pull stream, unlike a push stream, is a stream where the consumer asks for a data. So it may be hard to see, but this example and this example, this one from all the way up, they're the same, right? It's still fundamentally a getter for the getter. And this is true across all iteration protocols, across all programming languages. It's like it's a fundamental observation about like what streams are. Right, and we have plenty of examples. Like an RxJS observable is a push stream. You subscribe to it once and it pushes values to you. And a sync iterator or like the CFile API are pull streams. You once, you get a stream and then you are the one who has to ask for the data over and over. Which is better? Anyone wants to guess? Anyone wants to take a side, like to say it's push, it's pull? So. Good job on you, like it's a trick question. When no one understands stuff as well as we'd like, we always say it depends, right? That's a thing in computer science. We make excuses and we say it depends when we don't know. So the answer here is it depends, right? Let's look at some some use case, right? So I have this code. Obviously, it's not real code. I put stream magic to make that extra clear. And it takes some parameter from a web request to Node. and then it logs that request to analytics or something, and then it compresses it with compression, roughly is like a gzip, and then it sends it to the request. It like responds to the request. What happens if like some part of my pipeline that does like compress and maybe like make a query and then send it, what if it's slow like 10% of the time? So that's a problem every framework, every language has to solve when it does streaming. So the most basic idea about streaming is let's buffer some data. Let's like read maybe 5 kilobytes of like the create read stream part of like the file in order to maybe if log to analytics may be slow, we won't block on that. Or we log to analytics like ahead of time on stuff before the compression finishes. So a problem platforms have to fix is like syncing the speeds of all streams. So the term for the amount of data we buffer is called a watermark. You may see this, we are very bad at explaining these things that I swear they are not fundamentally hard. A watermark is just the amount of data that you buffer in the stream, right? That's the high watermark. There used to be a low watermark, it's 0 now. I don't want to confuse you extra, like it's, but basically, the high watermark in a stream controls how much you buffer. It's true for node streams, it's true for like WhatWG web streams. And it basically just asks for more data until it reaches this number. It's good, but it's risky, right? The whole idea, remember, of streams was processing data 1 bit at a time. If we start buffering all the data, we miss the point, right? If you're reading like a gigabyte file and you have a server and the server has 4 gigabytes of RAM, you don't want to, like, your max concurrency of users is 4 if you read the file to memory every time. Yeah, I think I already answered that. Right. This is a graph of the Chromium MP4 algorithm. This is what happens when you open a .mp4 file. It's just here to illustrate. There are very complicated, it's more complicated than that's an old photo. There are very complicated algorithms based on like how much data you buffer that video players do, right? And it's actually a bit more complicated because they don't just buffer, they switch between renditions, different video qualities. But every abstraction that needs to load data without loading it all into memory at once needs to make this trade-off. Right, what if this, like the compression bit is slow? And I don't want to read the whole file into memory because I'm waiting to compression. And if we read every file every time into memory, we're like, miss the point because we want to process data in parts. We need some way to tell the stream to stop sending us data, right? In pull streams, that's the one where you did next, the getter to the getter. It's very easy. We just stop pulling stuff, right? We do pull, next, whatever. And then we just stop pulling. We wait for whatever we need to happen, and then we're done. In push streams, we need a separate API on the stream that makes it more complicated. It can't just be a setter for a setter. We need like some way to say like pause and then resume. And you will see like different versions of Rx across languages that do this differently. It's very unintuitive, right? It's like, hey, event listener, please send me these clicks like later, maybe. Speed syncing between streams, like making sure all these like coordinate well, is called either pressure or back pressure. Back pressure, like watermarks, is one of those simple terms that somehow gets like, and again, it's because we didn't understand it well back then, it gets like a complicated reputation. Pressure is I want to emit, but I can't, and back pressure is I'm getting data too fast, please slow down, I can't process the data right now. And that's what those things mean, basically. So, what sort of data can we even put in a stream, right? You would theoretically say like anything. You can put numbers in, you can put like objects in. And the truth of the fact is, platforms like Node, we have to deal a lot with binary data. Like you have an HTTP request, you get bytes, you output bytes. So it's a trade-off. Like RxJS streams and like iterators in JavaScript, they work on JavaScript objects. That's like the primitive we have in the language. In Node, all our streams are for uint8 arrays or buffers that extend uint8 arrays, which means you work on bytes. So the amount of stuff you buffer it's like the number of bytes. It's not the like number of chunks you have. And like I swear, that's basically it, right? A stream is something you can either pull from, which is just a getter to a getter, or push to, which is just like passing a callback to a thing. And then the amount of stuff it buffers is called the watermark, and the amount of the need to tell the stream above me that I don't need more data is called back pressure, and in a pull stream it's trivial, I just don't pull more data. Here is a quote from the Zen of Python. It's a famous quote, so I used it. There should be one, and ideally only one way to do something. Actually, it's out of memory, maybe I got it wrong, but let's explore the creativity and fun that is Node.js streams. So, you know the joke when someone tells you, like, do you want A or do you want B? And they answer yes, where yes isn't A or B. So imagine designing your core abstraction of like one of the most popular platforms around this, around like doing everything. So node streams, so like guess it. I already showed the slide, but so maybe not. But anyone wants to guess if node streams are pull or push? Yes, exactly. Anyone wants to guess if node streams are for objects or for bytes? Yes, exactly. And it's actually more than yes. So node streams have 3 reading modes. You can either get data pushed to you with the data event, or you can pull data. You wait for readable, and then you call .read. And there is actually like a 3rd mode, like a shrug mode, that's literally marked by something being equal to null. And the decision of like whether it's push or pull is based on adding the event listener. That's crazy. That's like the fact you do on data turns the stream from like shrug mode, I guess, to like push mode. And the fact you listen to readable turns it to pull mode. And like, of course, they have different terminology. It's flowing mode. I say there, like I don't maintain this shit. So the decision is based on adding the event listener. And again, that's so confusing. If you ask a room of like 100 developers that do Node.js like for years, like 4 of them will know this. And people in Node.js core will like mess this up constantly. So again, policy versus object, we said, yes, I have a friend, his name is like Jake Reynolds, he's a nice guy. And like when they were working, when Dominic Tower was building Streams 2.0, he said, hey, it would be cool if it also supported objects. So they just added a flag called object mode, like messed a bunch of like caching stuff, and Node has object streams. So now we have 3 read modes, like flowing, non-flowing, and whatever, and object mode. Streams can either be this or they can be that. We also have legacy streams. So in addition to all the mess I talked about now, there is actually like the thing that this complicated mess replaced in Node 0.8. If anyone here was like, did anyone here do Node like 2014, 2013? I'm so happy for you. Right. So there's also like an old legacy mode. So the legacy mode isn't crazy like Java URLs where like they will make a DNS request, but it's pretty bad. And to be clear, the people who wrote that were innovating in a new space. They're very smart. They're very most of them are like likely way better programmers than me. And it's not that they were stupid, so they made the mess. They wrote like complicated software that hit like a lot of usage, and that's why we got the complicated mess. And this is true for like most APIs. So what about using streams? So this is why people hate streams, basically. I have a stream of numbers, and I want the stream of numbers times 2. This is a very simple request. It could be a for loop in C. It could be like array map. We'll see. So the way we do this with node streams is we create a new stream. And the way we used to do it is we had a subclass, something called readable. We'd override the method called _read. We'd call the constructor, tell it to be in object mode, so it's not bytes. Then we have this stream protocol where you push null to indicate it's done. So I take the array, I dot shift, that takes the first item, and that's a mess. And in order to transform it, I need to pipe it to a class that extends transform, and I override the transform callback. And like pass it chunk times 2, which is also confusing, and this sucks, right? This is not a fun API, right? When we had a getter for a getter, things were nice, right? It was just like this simple code, and suddenly we have something that essentially does the same thing, but suddenly we have to subclass 2 things, and like very confusing, right? So we can simplify it a bit. We have simplified construction. We can do new readable. We pass it object mode, and then we still have pretty much the same code, this dot push, and then we do the same thing with the transform, simplified construction. Instead of subclassing and doing underscore transform, we like pass it as object, as shortened method definitions. Much better, right? Yes. No, it still sucks. This is still not fun. It's still like it's not the code you want to write. Let's try again. To create a stream in modern Node.js, all you have to do is like you do array.from, you do readable.from. That's simple, right? I don't have to subclass anything. I don't have to like do anything complicated. That actually looks okay, right? When I do this code, it doesn't make me angry. When I write this code, I am angry. So better. If I want to transform the stream, we have this function called compose that lets you take a stream and map it. All I've been talking about is readable streams. Writable streams are not as interesting, like they're interesting, but not in Node. And you can do compose. You pass it like the data you want the first stream to have, and then you can for-await like the data inside. And that's how you transform it. And this is much simpler and much smaller than the example we had above. And again, this doesn't make me happy, to be clear, but it also doesn't make me sad, like the example above. Can we do better? So, what would you do if you had an array of numbers, 1, 2, 3, and you wanted to get an array of numbers times 2? Map, yeah, exactly. We just map it. That's fundamental, and it's also profound. Do we want 5 slides of philosophy? Yes or no? Yeah. OK, cool. So some philosophy. I'm going to hand wave a lot. There are many things you can map just like arrays. You probably noticed that. Anything you can dot map, which is basically take a structure and apply a function, is called a functor. You can basically do cool stuff like map a structure onto itself. So you have an array, and you also return an array from the method. In an array, that's .flatMap. In an observable, for example, that's switchMap. And it abstracts the process of flow control. Yeah, so an array's flatMap that takes an array, unwraps a value, and then that returns another array is like a promises.then. Say it takes a promise, it unwraps the value, and then it returns another promise. And it's like an Rx switch map. It takes an observable, opens the value, and it returns another observable. And things that map are called functors. Things that map a value to themselves are called end-of-functors. They map to themselves. Things that chain, that map but also chain, are called monoids. Now, here's how to sound smart without saying much. If you chain into yourself, like promises or observables or arrays with flatmap, you are called a monad, which is like a crazy, scary term for no good reason, because all it means is that you map something onto yourself and then open it. If you want to project insecurity in a meetup, all you have to say is a monad is just a monoid in the category of end-of-functors. That's the quickest way to project insecurity. 2 years ago, a friend called Robert flew to a conference I help organize in Israel, and basically we were talking about Compose. He was talking about this new API, and I basically asked him, why can't we give people the API they want? They just want .map. Like, why are we complicating everything so much? He said he's not sure, because Robert, he's a saint, to be fair. Robert wasn't there for Streams 2.0. He joined much later. He joined after me, after Matteo, and he basically like did all the scary stuff we were always scared to do and wanted to do. So basically, as soon as he said it, I just opened a PR. And I opened the PR, and surprisingly, it got merged. So we got .map on Streams, and we'll see it soon. And open source is awesome. Like, a ton of people, basically, I pinged them, and I said, hey, we're doing this new thing. We're adding operators, map, filter, reduce, and so on. And can you contribute one? And a lot of people did. And we have some like heroes here. And especially thank you to Antoine, who is pretty new in the project, but is like getting dominant, which is great for reviewing a bunch, and Matteo for maintaining streams for a long time alone, unthankful. And of course, like Robert, who co-authored like all of this with me and the contributors. I want to point out that open source is awesome. I only showed the examples from Teams because those are the ones that worked. But I spoke to the guy who worked on it in Python, Guido, and I spoke to the guy who worked on it in C#, Bart. And I approached them and I asked for feedback about us doing this thing. And both of them responded and gave us like really good feedback that influenced the design directly. So props to them, super thank you. They owe us nothing, and like they were willing to help. So open source is really awesome in that regard. And this is the API we have now, right? If you have a stream, you can just take it, you do readable.from 1 to 3, and then you map it. And finally, that looks fun, right? This is the API we want. Like we probably can do better. This is great. This is the API we wanted. And it's based on this really cool TC39 proposal for iterators called iterator helpers. It's stage 3 now. It used to be stage 1 or stage 2 when we started working on it. For those of you who don't know, stage 3 is pretty good chance it's in the language. Stage 1 means nothing. Stage 2 is like somewhere in the middle. Lots of politics, like language specification isn't fun, whatever. And iterator helpers basically define, like they say, async iterators, they will get .map, .filter, .reduce, and so forth. And we saw that and it was like, hey, now we can add it in Node and say it's like a standards thing. So we added all these operators to Node streams. And any Node stream you have right now, you can use this. So if you have a stream, like create read stream, you want to transform it, you can just .map it. If you want to remove some data, you can .filter it, and so forth. Like everything you know from arrays will work, as well as a bunch of other things specific to Node streams. So here's just like a basic example. I have a bunch of domains. I want to resolve their name, like their IP address. I can just .map like all the domain names to like a DNS resolver and then .toArray it, right? So toArray is dangerous because toArray fundamentally reads all data into memory, which again wasn't the point with streams. But for this sort of stuff, this is very convenient. And you might notice that like this isn't like resolver.resolve for that returns like a promise. So all these operators will wait for promises like when you pass them. So super easy, super nice. And there is more. So we took the proposal and we extended a few things in it. The few most common feature requests we get for Node is like, how do I limit the concurrency of this thing? And there is a pretty popular package for it. And like, how does cancellation work? We had this really big effort I was involved with like a year or two ago, where we added a board signal and a board controller supports to everything. So everything in Node, like file reads, DNS queries, everything basically that we can. We support cancellation for. So please use that. You can like limit the concurrency. So in this case, I have an array of 100 stuff. The function do something with X, that is returns a promise, will only happen 4 times at once. It's risky. It's not per server. It's per like this chunk of code, but it will only run with the concurrency you specify. And you can do deep cancellation. It means you can pass an abort signal to readable.from, and that will cancel any ongoing operations, which is really good if you have a server and someone like shuts down the request. So there's a bunch of goodies. I won't go over them now. I'm not sure if I'm out of time, but I assume I am. So this is really cool. There's a bunch of like APIs. I don't want to go over all the APIs, and I want to take questions instead. So before the questions, I just want to mention, if anyone wants to contribute to Node.js or any of the open source projects I talked about, I know I'm like slightly off topic, please reach out. It's not a closed club. You don't need to be like a super great programmer. You don't need to know streams well or anything. I didn't know any of that when I joined. Like, don't hesitate to email me. You don't have to like copy the email. It's in the Node.js GitHub homepage. But like, by all means, feel free, reach out to me, and I promise I will help you like make a contribution. Right. Questions about streams? Go. Yeah.
We have to wait because of the live stream.
Yeah, that's okay.
Hi. So how did you handle concurrency on the low-level side?
How are you doing concurrency where?
Like low-level in streams. Like how is it handled? As
Yeah,
like
so basically there's this trick where you just have two queues, like when you do concurrency. So all the streams code, it's in JavaScript, right? It's not in C++. We don't like maintaining C++ code because it's not fun to debug. So like there is an interop layer between like the C++ and the stream code, but the streams themselves are in JavaScript. There is a trick with promises, and you can look the code again. It's open source. Where you just have two queues. You spin up let's say four workers, and then like when one finishes, he just takes the other item from the queue. That's like the one queue, and then if there is no item and an item might come, you push the worker to a queue, and when an item comes, you look in the queue and you take it. It's very hard to explain without sharing code, but it's open source, and like you can see the iterations, because the first iteration didn't have a queue, and then like Robert added it in a further iteration.
Okay, thank you.
Sure.
Any more questions? Okay, then that's it. Thank you, Benjamin.
Thank you.
Also feel free to approach Benjamin
Yeah, please do.
in the hall.